Thyroid hormones, function and feedback. When the neurosecretory neurons of the hypothalamus secrete thyrotropin-releasing hormone or TRH, this TRH travels down to the axon terminal of the neurons, where it is released to enter the hypophyseal portal system of the brain. This hypophyseal portal system is essentially a bridge between the hypothalamus and the pituitary gland, particularly the anterior portion of the pituitary gland, passing through its network of capillaries to reach the anterior portion of the pituitary gland. In the anterior pituitary, the TRH binds to receptors on the endocrine cells within the anterior pituitary, stimulating the endocrine cells to secrete thyroid-stimulating hormone or TSH. The TSH eventually enters the systemic circulation, ultimately reaching the cells of thyroid gland. In the thyroid gland, the TSH binds to receptors within the gland, thereby secreting the thyroid hormones triiodothyronine or T3 and thyroxine or T4. The difference between the T3 and T4 hormones of the thyroid gland are as follows. 1. T3 has 3 iodide molecules in its structure, while T4 has 4. 2. Although T3 is less prevalent in the body than T4, it exerts a much stronger effect on the body than the latter. When T4 enters the systemic circulation, it gets converted to T3, which exerts the following effects in the tissues. 1. It increases the number of mitochondria within cells. 2. It controls the rate of cellular respiration, or in other words, controls the metabolic rate of the cells. It accomplishes this by increasing the activity of sodium-potassium ATPase pump, thereby increasing the hydrolysis of all available ATP, resulting in an increase in the basal metabolic rate or BMR, as well as generating heat as a byproduct of this process. All this creates a need for more ATP, which is mobilized through the energy stores of the liver and skeletal muscles through glycogenolysis, the adipose tissue through lipolysis, and the breakdown of skeletal muscles to amino acids through proteinolysis, thereby providing substrates for cellular respiration. Thus, thyroid hormones contribute to 1. The growth and development of the body's tissue. 2. Creates a balance between the catabolic and anabolic reactions of the body. Increased T3 and T4 levels in the blood results in the hormones binding to receptors in the hypothalamus, thereby blocking the release of TRH or inhibiting the responsiveness of the anterior pituitary to TRH, thus creating a negative feedback which inhibits the rising levels of the thyroid hormones in the blood.